Woohoo, we are live. This is Math 60, Intermediate Algebra, and we're in 1.5 talking about solving linear equations using properties of equality. Woohoo! And this should all be review. 1.5 should be review of algebra you've already studied. So this is just a quick reminder. This is not going to be enough if you are learning it again after a very long time, or if in some cases you maybe just never learned it. You're going to want to talk to a tutor. You're going to want to come talk to me in office hours. You're going to want to get more. So this is just a quick brush up of skills, just to remind you, oh, that's right, this is what we do. So we're going to start off with the question. When you're solving an equation, what steps are you allowed to use? So let's go over the steps you're allowed to use. You are allowed to simplify. What does that mean? Well, simplifying can refer to a lot of things, but in this case, simplifying means combining like terms. 2x minus x equals 6 can be simplified to 2x minus x. That's x equals 6. And so there we go. We've got the solution to the equation, and I set it up so that it would happen very quickly. But basically, this is a process we would do. We would use simplifying either on the left or the right or both. And this allows us sometimes to get to solutions very quickly. Another technique we could use, adding to both sides. So if I have, for example, a situation like x minus 4 equals 10, I'm allowed to add 4 on the left and add 4 on the right. And generally, we draw a line underneath, and that helps people to see, that's what I've done. If you would like, you can also draw a little dotted line all along the equal sign. You don't have to, that's not required. Over here on the left, if I have x minus 4 and then I add 4, the minus 4 and the plus 4, let's see, what color can I use? I'll use orange here. This minus 4 and the plus 4 together cancel out to 0. And so all I have on the left is an x. I have an equals in the middle, and then 10 plus 4 is 14. So in other words, x equals 14. Woohoo! These are obviously not representative of the kind of problems we're going to get in the homework. These are just review problems. Number 3, you're allowed to subtract from both sides. And I bring this up only to point out that technically you are not subtracting, you're adding the opposite. Just want to say that. But a lot of people call it subtraction, so we go ahead and work with it that way. If I have y plus 3 equals negative 6, I could write minus 3 on the left, minus 3 on the right. And again, now I'll use blue, so I haven't used blue yet. I chose the 3s carefully because I had a plus 3. I'm going to add a negative 3, and they'll cancel out. So all I have left on the left is the y. And over here on the right, minus 6 or negative 6 minus 3 is negative 9. Woohoo! I wish they were all this easy, huh? Yeah, me too. Okay, number 4. You can multiply both sides by the same number, which is also known as clearing fractions. And I realize these are very small in the video, so let me see if I can rewrite it. This is 1/2 x equals 16. Or another way to write this is x over 2 equals 16. And I'm going to go ahead and write it over here. Give myself some room. And what you are allowed to do to both sides is you're allowed to multiply both sides by the same number as long as that number is not equal to 0. And I'm going to choose to multiply by 2. Now you'll notice that I use 2 different forms of the same number. The value is the same. I'm going to use 2 over 1 over here because this has to talk to fractions. So this is the fraction version. And I multiply by 2 written as a whole number here because it's going to interact with another whole number. So over on the right, I get 32. And on the left, I can cancel the 2 down there with the 2 up here, and that cancels out the x. So if half of x is 16, the whole x is 32. Woohoo! Yay! Okay. And then the fifth property of equality that we're going to use is going to be dividing both sides by the same number. And again, we say dividing, but in fact, we're multiplying by the reciprocal. So we're multiplying by 1 over that number. So if I have 2x equals 16 on both sides, I can divide by 2, which in fact is just really multiplying by 1/2. Now on the left, the 2's cancel completely, and I'm left with just the x. On the right, the 2 cancels, and I get 8. And of course, these are pretty straightforward. So if I told you I'm thinking of a secret number, twice that secret number is 16, what's the secret number? You could probably tell me, oh, it's x equals 8. But those were the 5 basic building blocks we have to solving equations. We're going to simplify things on each side, and then we're going to do the same thing to both sides to whittle it down. And the goal is that we're going to isolate the variable. And isolate means get it by itself. Like here, the x is alone on the left side. Here, the x is alone on the left side. Now, as far as I'm concerned, it doesn't have to be the left side. You just pick one side, whichever makes the most sense. Okay, are you ready? Shall we try some? Woohoo! You guys ready? This is going to be kind of shocking. You might want to avert your eyes at first, because if you were watching me do all those simple problems, this is going to be a little cringy. Dun, dun, dun! So let's take a look at what the heck is going on here. I have the instructions are to solve and check, and that's important to know. I have 3 plus p all over 3 minus 4p equals 2 minus p plus 2 all over 2. So right off the bat, we got a lot of things happening. I usually use wish fulfillment when it comes to equations. I would say to you, what is the part of this that is the most scary? And I think a lot of students would say the fractions. This 3 and this 2 in the denominators, these are just, it's hard, makes it harder to work with. And I would say, great, if you've got an equation, you can clear fractions. So we've got a 3 and we've got a 2. So I need a least common multiple or a least common denominator. 3 and 2 both go into 6. So the LCM / LCD equals 6. Least common multiple, least common denominator. And then I'm going to take the 6 and I'm going to just spread it out. Imagine you are Oprah. Everybody gets a 6. Notice that when I'm working with a fraction, I write it in its fractional form. And when I'm working with whole numbers, I write it as a whole number. Okay. And if I've done a good job, then the fractions will all reduce. So let's see here. I've got a 3 goes into 6 2 times. And then over here, a 2 goes into 6 3 times. So then I've got, now this is tricksy. I've got 3 plus p here. Be very careful with this. This is basically a compound numerator. It's got 2 different terms up there. So I'm going to be very cautious with this. I'm going to use parentheses. Same thing right here. I've got P plus 2. I'm going to go ahead and write it like that. Okay, so now distributive property. Again, you do not have to write out the arrows. I just find it helps to trigger people's memory. Same thing over here. We've got 3 gets multiplied times both of these. So 2 times 3 is 6 plus 2p. Then minus 6 times 4p is minus 24p equals 6 times 2 is 12. And then minus 3 or negative 3 times p, negative 3p, negative 3 times 2 minus 6. So take a look. So far, what are the properties of equality I've used? I used multiplication right here. I multiplied everybody on each side by 6. Then I'm simplifying each side. This is the process of simplifying. Once I spread a 6 everywhere, I know I'm going to have to clean up some messes. So I'm cleaning up a mess. I'm going to combine like terms. Let's go ahead and use a green one here. I've got some p's over here on the left, and I've got a 12 and a minus 6. So I got to clean these up on each side. The 2 sides are not talking to each other. So just this side, I've got 6 plus 2p's minus 24p's is negative 22p. And then over on this side, I've got a minus 3p and then plus 6. And then why did I put the minus 3p first? I don't know. I saw it first. The terms can be written in either order as long as you're careful about the minus signs. Now, this is not a fun one. But so with this one, what I want to ask you is, where are the p's happier? These are very unhappy p's. Negative 22p is a very unhappy creature. Negative 3p, also unhappy, but negative 3 is actually bigger, greater than negative 22. It's better to owe $3 than owe $22. So I'm going to move all the p's over here to the right. Could you move the p's to the left? Absolutely. It's totally your choice. You move them to either side. I'm going to move them over to the right by, and here's another property of equality, I'm allowed to add to both sides as long as I'm consistent and I add the same thing. So over here I've got 6 equals, let's see, I think this is 19p plus 6. I'm going to reach over here and see if I can find some paper because I need to go on to the next page. So I've got 6. So this is 1 continued. So I've got 6 equals 19p plus 6. Okay. Now, do not panic. Your brain is going to notice something. It's going to be like, hey, how come this is 6 and that is 6? Oh no, I'm worried. Don't let your brain worry. Say, look, right now, we follow the order of operations. We follow the properties of equality. We can make this work. So I look and I see that I want my p to be all by itself, but there's a 6 in the way. So I'm going to subtract 6 from both sides. Now, does that mean that everything explodes? No. What is 6 minus 6? 6 minus 6 is, you got it, 0. So just put in the 0. Over here, this zeroes out, so this cancels out. Let's see, what color have I not used yet? I haven't used blue in this problem yet. Those 2 cancel out, so all I have is 19p. Okay, don't panic. 19 times some secret number is 0. Well, the only number that works like that is 0, so p is 0. But how do we prove that? Well, we go to a property of equality. I'm allowed to divide both sides by anything. What should I divide both sides by? You got it, 19. And if you didn't say 19, that's okay. You're still awesome. I divide both sides by 19, which means that over here on the right, I get p all by itself, right? Remember, isolate the variable. And then I need to bring in my shark friend here because we've got 0. And the question is, are we going to get eaten by a shark? And the answer is no. We're absolutely not going to get eaten by a shark because 0 is on top. That's no problem. 0 on top is just 0. Woohoo! P equals 0. Are we done? I'd like to be done now, but I'm not done because if we look at the original problem, which you can see up here in the corner, what is that nasty little word right there? Check. Generally speaking, you should always check your equations. But if it, in my class, if it tells you you have to check, then part of the points are actually going to be given to you to check your problem. So I will look for, on your paper, I will look for you a place where you've actually gone and written out the check. So let's write out the problem. 3 plus p all over 3 minus 4p 2 minus p plus 2 over 2. So first thing is you write out the original problem. And then you plug in p equals 0. So I get 3 plus 0 all over 3 minus 4 times 0. Now, I was always taught you can't assert it's true, so I'm going to go ahead and put a question mark there. 2 minus 0 plus 2 over 2. If you learn to do this slightly differently, do it the way you learned. This is the way I was taught, 483 years ago when I was in school. So let's see. I think this becomes 3 over 3 minus 4 times 0 is 0. So that's 1 minus 0. So that's 1. So my left side is equal to 1. I'm going to hope that my right side is also equal to 1. So let's give this a try. This is going to be 2 minus 2 over 2. Well, 2 over 2 is 1. 2 minus 1 is 1. Oh, they match. Woo! Now, generally speaking, most people do not write woohoo. Most people write a little check. It's kind of a visual pun. It says, I have checked it, and it is correct. If it doesn't work out, don't put a check. Your teacher will think you don't know what's going on. We go through your checks. If they don't work out, if something weird happens, what we'd like you to say is, oh no, it didn't work out. There must be a mistake. If you get 2 different answers, then it did not check, and write that down. Because the logic is more important than just, rubber stamping it good. Now, this is the kind of problem where the answer is kind of hiding, so I might put the answer right here in the middle, like that, and put a box around it if you want a double box, because we're very proud of it. I'm pretty proud of it. Woohoo! Okay, so that was that one. We're at 18 minutes. I think I'm going to push forward, and I'm going to go ahead and finish this section so that we don't have another video just for this problem. So let's go ahead and push forward with this. You can always press pause and come back. In fact, that would give me time to blow away all of the rabbit fur that is everywhere. So for the second one, I think for a lot of people, this is a little more approachable because decimals are more of part of our daily life. So I think a lot of your eyeballs are trained to look at decimals more. I don't know. I find decimals a little bit intimidating because I've practiced so much with fractions. But this is a very similar problem, and I want to explain the very first step you probably want to do, which you do not have to do. So if you want to do this whole problem with the decimals and a calculator, probably go for it. What I'm going to do is I'm going to look at the decimals involved, and then I'm going to clear decimals. So I've got 0.02x plus 0.0175 times 110 minus x equals 2.175. And I'm going to see that there are 3 digits here to the right of the decimal point. I'm going to see there's 4 digits here to the right of the decimal point, and here I've got 2 digits. So if I want to clear decimals, I want to use the most. And I know this is awkward, but that's how I think of it in my head. What's the most number of digits? The greatest number of digits is 4. So we're going to multiply by something that has 4 zeros. See how that's 4 zeros right there? Okay, so 10,000 is the number we're going to multiply by. Again, you do not have to do it this way, but I wanted to show it to you. 10,000 times 0.02x plus 10,000 times 0.0175 times 110 minus x equals 10,000. Oh no, I'm running out of room. 2.175. Now, a lot of folks look at this, especially in the middle, and they're like, wait, don't I have to multiply by 10,000 outside and inside? Here's the thing. Whatever number is out here, it's going to go through using the distributive property. So if we mix this 10,000 in here, it will get carried inside with the distributive property. You don't need to multiply it twice. So each term, this one, this one, this one, each one gets a 10,000. Let me circle them again. Okay, those are not circles. Yes. Let me box them. There we go. Okay, now, if you're like me, you have some trouble counting your decimals, you can count or you can multiply. You can leave your friends behind, because if your friends don't know how to multiply, then they're no friends of mine. Okay, so we get 200x here. Or I could, since there are 4 zeros, I can move this 1, 2, 3, 4. 1, 2, 3, 4. And I would have ended up with 200. Okay. 0.0175 times 10,000 is 175. And that 175 is a mix of these two. It's a blend. And then that's going to come multiplying through. So that's going to pull that 10,000 through all the way. And then over here, 2.175 times 10,000 . Unfortunately, this one gets really, really big. That's the downside. We had small numbers here. If we multiply by 10,000 to clear the decimals, then, and I feel like I should put this in yellow too, for clearing the decimals, we're going to end up with some very large numbers. So it's a trade-off. Once we've done this, if you try it again with the decimals, you'll see really it's the same problem with the decimals without. It's just some forms are easier. So it's a personal preference. And I wanted you to be able to see this so it was just another tool in your toolbox or your tool chest or your tool magical suitcase, or whatever you want, a little jaunty tool bag, or a cute tool backpack with like glitter and stuff. Okay, so I get 200x plus, now I'm going to multiply this out. 175 times 110 is 19,250 minus 175x equals 21,750. Next up, I can use pink. Next up, I've got a 200x and a minus 175x. I can simplify, right? After I multiply everybody by 10,000, pretty much what's happening here, these steps are going to be simplification steps. 200x minus 175x. You got it. It's 25x plus 19,250 equals 21,750. Okay. Now I've simplified the left. I've simplified the right. Now I want to isolate the x. Generally speaking, You move terms first. So I'm going to move this 19,000 first. Could you divide everything by 25? Sure, you could, but it's going to be a lot more work if you don't do this first. So I get 25x equals, and then these two are lined up, notice. They are lined up and they cancel out. So woohoo. Over here, I think, and again, I'm going to check. $2,500. So we get 2,500 there, 2,500. And now what am I going to do to both sides? I need to isolate x. So I need to do the opposite of what's here. This is 25 times x. So I'm going to divide. 25x over 25 equals 2,500 over 25. Divide both sides by 25. X equals 100. Yay! Except, what do we have to do? Oh no, we have to check. Okay, so 2, continued. I get the original problem, 0.02x plus 0.0175 times 110 minus x equals 2.175, and let's plug in the 100. Now, some people are asking, well, wait, can't we use like this equation or this equation? That'd be way easier. Well, when we're checking, we want to see if we've made any mistakes. By this point, we could have already made the mistake. So we got to check the very first problem we were given, the original form. Okay, I plug in, what was it, 100. So I get 100 here in place of x plus 0.0175 times 110 minus 100. Again, I'm going to personally write question mark, sorry, and 2.175. Notice there's nothing to do on the right. All my work's going to be on the left. So let's see, 0.02 times 100. I'm going to bet that that's going to be equal to 2. But again, I'm going to double check it. Yep, that's 2. Then here, order of operations says I have to take this, the 0.0175, and I have to first subtract right here. And that says I'm 110 minus 100 means I'm multiplying by 10. So then I get 2 plus, and multiplying by 10, what does that do? That just moves the decimal point. So the number gets 1 digit bigger. So it'll be 0.175. And so 2 plus 0.175 is 2.175. Oh my gosh. I taste victory. Woohoo! It's checked. My problem is correct. Okay, so we're almost done. This did take a lot of work, but there's one more question I want to ask you, and that is, what do you do when an equation doesn't have a solution? Other than run away or cry, these are all options. Maybe eat a lot of ice cream and chocolate, go find a supportive friend who can walk you through it. But basically, what do? You write no solution or cannot be solved. Now, something similar. There are a couple other phrases like that. How do you know that that's the situation? Well, what kind of an equation would you get? How would you know? I just want to remind you, how would you know this would happen? Well, this would happen if you did simplifying and somewhere along the line you got something that wasn't true. There are no variables and it's a false statement. Oops, that M got very excited. So I get something like 0 equals 6. Does 0 equal 6? 0 does not equal 6. 0 equals 0, 6 equals 6. So if you get two numbers that are set equal and the variables have all canceled out, then you know there's no solution to that particular equation. At least you know that, or possibly that you've made a mistake. Okay. Well, that was 1.5. Woohoo, you guys, we made it. Next up, 1.6, geometry. We're going to review some geometry facts and do a couple of problems, and then we are done with chapter 1. Woohoo! Yay, I could bring in good old Vlad, and we haven't had the bear, and it's just like full on dance party. Woohoo! Okay, so next up, 1.6. Math on, guys, math on.